So remember last chapter, we were doing binomial distributions. And just to give an outline again, if your probability was 0.05, then it was perfectly symmetric. And it just got better and better as your population got larger. And what I mean by symmetric was looking like the bell curve, like that, okay? And the more and more that you had in your sample, the stronger your bell curve was going to be shown. For an example where you have a probability of, instead of 50%, 5%, your data is going to look kind of skewed. So maybe it looks something like this, okay? Because your probability, your mean is going to be right here versus your mean in the last one was right in the middle. Because remember, the mean was n times p. So your probability times the number that you were using. But what ends up happening is as n increases, or the more in your sample size increases, it will look more and more symmetric. As you test more and more items, it will get more and more symmetric. So some rough guidelines are the normal approximation is reasonable if, I don't know if you saw this before, but the mean is greater than 10, or n times the quantity of 1 take away the probability is greater than 10. So what this means is, if you look at this right here, okay, is that if you have a very, very small probability, or like 0 or 1, not in the middle, but very small, like 0.5 or 0.005, you need a larger sample to choose from in order for the normal approximation to be reasonable. So that's what that guideline means. Let's say we wanted to estimate the number of left-handed people. If we had a sample of 500 people and 45 are left-handed, we would say that the sample mean, we call it p hat, would be equal to the number of people that were left-handed over the number of people total. So 45 out of 500. And we get about 0.09, I believe. Now, to make sure that we're doing this correctly, we should always do that normal approximation. And if you look, we've got a very small number, like 0.09 for our sample probability. So we really want to make sure that this NP is greater than or equal to 10, and have the number of people times the probability greater than or equal to 10, and I think we get 45. We also want to do the opposite, n1 minus p greater than 10, so 500 times 0.91, and that's definitely going to be greater than 10. And we also want to check this 10% rule. So we're trying to make sure that we're talking about something normal or will be normal if we would take a big enough sample, because we're not really going for independence. We can't really tell, are these two independent of each other? But the 10% rule says take the number of people and times it by 10%. And make sure then that you have 50 people maximum. And if you look, we have 45 people in our sample. So that's really a good number. We want it big enough. Our 10% rule means we need to have it big enough so that we have less variability, but we don't want it too big. Now we can start looking at what the mean of the sampling distribution of p hat is. And it's just plain old p. And that's considered over here, the mean of this would be 0.09. That's our probability of success. This formula is on your formula sheet, like is 1,000 other mean formulas that are there. And this is for a sample. So this p hat should really give you the clue that this is for the sample. And of course, there's a new standard deviation formula, which I know people aren't going to really like, but again, it's got this p hat symbol with it. Now, p hat is not within this. You're using the proportion, your mean within this. So it would be, and this formula is on your formula sheet as well, with the p hat there, subscript written there. So we want to be putting in 0.09 and 1 minus 0.09, 0.91 divided by 500. And it equals a very small number, 0.00016, something like that. But we've got to make sure we square root that. And we should get 0.0212798, something around there, for our standard deviation. And these two things we're going to be working on, but the key to this is when you have a proportion, when you have 45 out of 500. So this is only for sample proportions. We'll be doing something different when we have sample means. We'll talk more about that the next time.